Welcome to Deep Dive Defense, military and aerospace enthusiasts. Over here we give rare insights you won't hear elsewhere. Today's topic is a combat drone based on the RQ-170, Iran's jet-powered Shahed-191. Of all the Iranian drones based on the RQ-170, the Shahed-191 is the most advanced and has been widely deployed. In late 2011, Iran succeeded in capturing one of the most advanced drones of its time, the US RQ-170 Sentinel, to the surprise of the world. This drone, produced by Lockheed's elite Skunk Works division, renowned for handling high-end and secretive military and intelligence projects, was designed for the challenging role of reconnaissance and surveillance operations in contested airspace. To achieve this capability, the RQ-170 employed a flying wing design similar to the B-2 bomber. Coupled with its advanced turbofan engine, this design allowed the drone to fly at comparatively high altitudes while being difficult to detect. Its low observable shape characteristics were enhanced by extensive use of radar-absorbing materials and structures. By the 2010s, US designers were aware that some of their adversaries had developed capabilities to detect even its most advanced stealth designs. As a result, the RQ-170 was also designed to be a relatively low-cost asset, making its loss in combat more acceptable. The RQ-170 could operate undetected in the airspace of most countries, providing valuable intelligence, such as during the operation, to assassinate Osama bin Laden in Pakistan. However, Iran, viewing the United States as its primary adversary, had taken significant efforts to counter low observable US aircraft. Despite this, in 2011, US decision-makers deemed it feasible to conduct a reconnaissance mission over Iranian airspace from Afghanistan, believing that Iran's eastern regions were sufficiently low protected to slip through. Hence, the RQ-170 took off from Kandahar, Afghanistan, and headed towards Iranian airspace. As a global superpower, the United States utilized space-based electronic intelligence, ELINT, to detect radar emissions and locate ground radar positions and observe activity. Additionally, assets like the RQ-4 Global Hawk provided airborne ELINT and standoff synthetic aperture radar data of ground activity. These tools gave US planners a detailed electronic order of battle and confidence that Iran lacked the necessary radar coverage in the region where the RQ-170 would intrude. Even if Iran could detect the RQ-170, it was believed that they lacked an air defense system within range and capable of successfully engaging the high-flying, low-radar cross-section drone. The precise details of how Iran managed to capture the RQ-170 nearly intact remain unclear. However, the most plausible scenario involves Iranian sensors detecting previous RQ-170 activity near or inside its airspace and setting an ambush. This likely involved an electronic warfare operation that jammed the drone's satellite data link and employed GPS spoofing to lower its altitude, causing it to crash land in a suitable plain area. This successful operation provided Iran with access to the then state-of-the-art RQ-170 made by the Lockheed Martin's Skunk Works division. Despite the interest from global aerospace players like Russia and China, Iran chose not to share the captured drone. Instead, they used the captured technology to advance their own aerospace and drone capabilities, which were still in unsophisticated stages in the early 2010s. The IRGC Aerospace Force-affiliated Shahed Industries undertook the task of reverse engineering the captured RQ-170 drone under the project name Shahed-171. However, it was evident from the start that, given Iran's potential adversaries, particularly the United States, even a successful one-to-one replication of the RQ-170 would have limited survivability in a high-intensity conflict. Although the drone could exploit vulnerabilities in an opponent's integrated air defense system when provided with a high-quality electronic battlespace map, it would still be vulnerable to airborne high-power radars and thermal sensors. Moreover, the drone's advanced and comparatively costly components, such as the FJ-33 turbofan engine, were beyond Iran's immediate capability to reverse engineer. Consequently, the reverse engineering effort was divided into three distinct variants. This 60% scale of the original RQ-170 retains the jet propulsion and relative high speeds, but its cost-effective design allows it to be produced in large quantities, significantly impacting the Aerospace Force's drone division. Although the RQ-170 radar cross-section reduction measures are more sophisticated, the 60% scale inherently reduces the radar cross-section, compensating for the less advanced stealth design features aimed at cost efficiency. The Tulu-10 engine is a crucial element in the development of the Shahed-191. This mini-turbojet engine offers remarkable fuel efficiency compared to other engines in its class. Based on a Czech design, the Tulu-10 also enabled the Pave cruise missile to achieve an impressive range of 1,600 kilometers, while utilizing turbojet technology instead of the costlier, efficient turbofan engines. The unique performance of the Czech engine and its Iranian copy, the Tulu-10, allows for the production of weapons like the Shahed-191 and the Pave land attack cruise missiles at exceptionally low prices. The engine's features, such as the single-stage compressor and single-stage turbine, facilitate low-cost, high-quantity production, elegantly addressing the propulsion needs of the Shahed-191. Initially, this engine enabled the Shahed-191 variants to achieve a combat radius of 450 kilometers and a cruise speed of 300 kilometers per hour. These figures are improved for the reconnaissance and surveillance variants to a radius of 750 kilometers and a cruise speed of 350 kilometers per hour, providing an operational radius comparable to that of third and fourth generation manned fighter jets. For navigation, the Shahed-191 employs a 4-antenna CRPA system to harden satellite navigation against jamming and spoofing. This system can identify the directions of jamming sources and adjust the array to receive true satellite signals by nulling the jamming direction. The necessity of such navigation hardening was underscored during Iran's 2024 strikes on Israel, where intensive jamming and spoofing of satellite navigation signals were prevalent. In contrast to its relative, the Shahed-181, which is a lower-end, low-cost, 60% scale variant of the RQ-170 with propeller propulsion, the Shahed-191 places a higher emphasis on low radar cross-section. To minimize protruding elements, the drone is equipped with retractable ski sleds for landing, eliminating the need for traditional landing gear and saving space within the airframe. Like many other drones produced by Shahed Industries, it is launched via an accelerating truck until it reaches a speed sufficient for its own propulsion to sustain flight. This method allowed the drone's design to be optimized for cruise speed, as the propulsion system alone would not be powerful enough for takeoff. The innovative truck-assisted takeoff mode enabled this design optimization. Additional measures were also implemented to reduce the radar cross-section compared to the Shahed-181. For instance, the movement mechanism for the ailerons was integrated into the airframe instead of protruding outside. However, the most significant measure for radar cross-section reduction was the requirement for the drone to carry its weapons in internal weapon bays. The Shahed-191 is equipped with 2 weapon bays to house Sadid-type optical or satellite navigation-guided miniature bombs. This combination of radar signature reduction methods ensures that the Shahed-191 can operate more effectively against advanced adversaries like the United States and Israel. Even if detected, the drone's expendable design compensates a potential loss. Its 2 mission roles allow one version of the Shahed-191 to carry a surveillance payload with a stabilized turret below its nose for reconnaissance missions, achieving a maximum operational radius of 750 kilometers. The second mission variant carries 2 small Sadid-type satellite navigation-guided bombs for attacking stationary targets, with an estimated reduced maximum combat radius of about 500 kilometers. Although these ranges are insufficient for directly confronting Iran's main regional adversary, Israel, directly from Iranian territory, the Shahed-191 still provides a useful tactical air power asset to the aerospace force. It is more cost-efficient than most one-way attack drones and has the capability to operate in contested airspace, where the adversary holds the advantage. The Shahed-191 also features 2 characteristic bumps found on the RQ-170, which on the US original house sensors, and a directional communication antenna. The Shahed-191 bump contains a parachute for emergency recovery when landing via sleds is not possible, while the other is believed to house a data link communication antenna. This enables the drone to maintain contact with the ground station or an airborne relay drone for extended communication ranges, estimated between 100 and 200 kilometers. This capability facilitates man-in-the-loop operations, where Shahed-191s equipped with optical sensor payload can identify and assign targets for themselves or other Shahed-191 drones with a bomb-only payload. This operational concept is somewhat supported by exercise observations, where formations of 4 or more Shahed-191s flew in tight formation, suggesting the potential presence of an automated formation flight system. A key advantage of the Shahed-191 over the Shahed-181 propeller variant is its ability to reach altitudes approximately twice as high, allowing it to more efficiently release unpowered glide bombs. Combined with its maximum speed of 350 km per hour, this significantly improves the range of the unpowered weapons, allowing the carrying platform to remain at a more secure standoff range. In summary, with its 500-kilometer combat radius when equipped with bombs, the Shahed-191 represents an effective weapon, which is why the Aerospace Forces Drone Division has deployed it in significant quantities. Looking ahead, it appears that the new Shahed-197, a hybrid of the Shahed-191 and Shahed-181, will become the main variant of this family of drones. The Shahed-197 offers a longer range adequate for confronting advanced regional adversaries like Israel, and lower life cycle costs due to the reduced maintenance requirements of its piston motor, thereby enabling continuous and effective air power projection. So that's all for today. If you liked it, give a thumbs up, comment, and subscribe. It really makes a difference in the YouTube algorithm and is a great support to the channel. The real enthusiast can become members and given access to exciting membership area material. Thanks for your support and motivation. See you next time.